Welcome to another video. In today's video, we'll talk about RxJS, which is reactive extension for JavaScript. It's a small framework-agnostic library for composing asynchronous and event-based programs by using observable sequences. It consists of observable, a lazy push-based stream of values, synchronous or asynchronous, subscription, a handle for starting, stopping, and cleaning up work, and what we will focus on today, operator, a pure function that transforms, filters, or combines streams. For example, map, filter, switchMap, debounce time, over 100 in total. In today's video, we will focus specifically on two operators. The first one is called switchMap. So what it does? First, it subscribes to your outer source observable. In another step, for every emitted value, it calls a projection function that returns a new inner observable. Another step, immediately unsubscribe, cancel any previously active observable and switches to the new one. In another step, mirrors all values from the latest inner observable. So let's put it differently. Listen to the newest thing, forget the old ones. Another operator that we'll focus on is our combineLatest. CombineLatest immediately subscribes to each source observable. Let's say few observables. It creates an internal buffer that will hold the latest value coming from every source. In another step, in handling a new notification value emission, stores the new value in the source latest value slot. Check the old resources already flag. If any source is still missing a first value, it does nothing. If every source has at least one value, it builds the output tuple. It combines in array all these values together. And as a last step, if a source completes, combineLatest simply marks the source as done and stay subscribed to the other variables. Now let me present it on a real-life example. Let's imagine that we have a place browser on our website and two sources of data. One API is, let's say it's a Wikipedia from where we download information about places, and second is the weather API. Here, we create a simulation of user typing new search phrase into search input box. Delay in the pipeline simulates time between every new value searched by user. So here is our functionality. User search returns value after certain delay and pipe handling each of them. SwitchMap accepts observable as a return value that can subscribe to. So we create each one of them for every API that we need combined data from a wrap by combineLatest as a single source that we subscribe. CombineLatest waits until every observable returns value from their API and returns a new array of value in a sequence as you pass observables to it. So now let's see the whole process and advantages of nesting it in a switchMap in a visualized form. Now let's see how this flow looks like. First, user is typing a name or a phrase that is looking for in a search input box. This causes that our first source emits value and passing it into switchMap transfer operator. Inside switchMap, we create two other observables based on a search text. In the meantime, user changes his mind and because why not, and decided to modify his search phrase. So our input source emits new value. Previous operation didn't finish. Observables were combined, subscribed by switchMap, and we're waiting for response time from our API. Here comes the beauty of this operator. New search phrase automatically causes switchMap to unsubscribe to previous observable and cancel all requests related to it. With this, we can save ourselves bandwidth and we will make application run smoothly. Second request gets combined by the combineLatest and result is returned to the user. Just like this. That's how the whole flow looks like. Nesting combineLatest inside switchMap is a powerful pattern for scenarios where the set of observables you need to combine is dynamically determined by any outer stream, and you only care about the results related to the latest value from the outer stream. However, be sure the cancellation behavior of switchMap is what you actually want. If the outer observable emits rapidly, you might repeatedly cancel and restart the inner combineLatest setup, which could be inefficient if the inner observables involve network requests or heavy computation. That's all in this tutorial. If you found it useful, leave a like and subscribe. See you in the next one.